For my latest project, I'm building a replica network rail inspection train, one of a small fleet of modified Class 153s used in the maintenance of our railways. But I don't just want this to look like the real thing. I'm going to make it operational too, with a camera streaming video, so we can see what it's seeing as it goes around my layout, on a smartphone or computer. Based on my existing WagonCam, it'll be using a lot of the same technology, centered on a Raspberry Pi Zero, running a bit of software called MotionEye. You can see exactly how I made that in the video linked above. And whilst I will be going through all the stages, I won't cover some things in quite as much detail, so I won't be too repetitive. But I will flag up where you might want to go back and watch the original to fill any gaps. Now this is going to be a two-part film. In this section, I'm going to mostly be doing the tech, with new developments like direct power from the track, and then in the follow-up, the modelling, including 3D printed items like the generator vents and cameras, and of course the respray in the distinctive pale blue livery, plus bespoke handmade decals. And if you just want to do the 153 conversion, you only have to watch that bit. But just like the real thing, it's the combination of the two that make the video inspection unit a cut above the average 153, and a fascinating modelling project. Obviously the first thing we need is the train itself, and I picked up this one from eBay for a fairly reasonable price. As we're going to do a conversion and a respray, it's in a cosmetically better condition than I actually require, but that'll only make life easier, with less filling and sanding to be done in preparation for the new coat of paint. It almost seems a shame to cover up that nice northern livery. Now let's run through the other parts we need. Like WagonCam, we start with a Raspberry Pi Zero. This time I'm using the one without the headers, soldering directly to the board instead, and you can see I've already had a trial run. Next we need a camera, and once again I've got the PiHut ZeroCam, although this time I have gone for the standard version. Then like before, an Adafruit PowerBoost 500C, which will manage the 5V input for the Raspberry Pi from the LiPo battery. So far this is all very similar to WagonCam, but this is where we start to do something different, as I'm planning to take the power from the track, with a smaller battery, effectively an uninterrupted power supply. For this we need to reduce the voltage, and I'm going to use this step-down voltage regulator to get down to the 5V required for the power boost. The input for this also needs to be DC, and I'll be exploring a couple of methods for converting the alternating current of the track that my DCC system uses. Then like my original WagonCam, I've got a small switch to turn the power boost on and off, only this time it's going to be mounted remotely. And that's just about all the components we need, although for one of my AC-DC conversion methods, I'll be using one of these, a bridge rectifier. Then the very last thing is a micro SD card for the MotionEye operating system, which we're going to load up now, plugging it into another computer, in my case a Mac, but it could be a PC or even a Raspberry Pi. The full installation of the MotionEye operating system is detailed in both WagonCam and my DoorCam video, which you can see on the link above. So I'm just going to scoot through the process here, downloading from the GitHub and installing on my SD card using the Raspberry Pi Imager, selecting my Raspberry Pi Zero from the list and dragging my download onto the operating system field, picking the SD card as my target. Once again, I've put all the download links in the description, in case you don't need to be reminded of the whole process. Then with the software installed, we need to do the configuration so it can join our network, and we can see what the camera is seeing on another device. This is essentially a short text file with our location and login for the network, which I've obviously made up for the demonstration. This is then saved and renamed as a .conf file, so the startup routine can identify it and join our Wi-Fi. That's the installation complete, so we can unplug our SD card and plug it into the Raspberry Pi. Then we just need one more bit of information, our device's IP address, and the easiest way to find this is by plugging in a screen and starting everything up. And here's the address we want, which can be typed into our browser, taking us to the MotionEye interface, showing the streamed images from our camera, the settings for which, including getting everything the right way up, I'll come to later. Software installed, let's get back to the hardware and wire everything together for a trial run. Whilst the Raspberry Pi is the business end, it's really the power boost that's at the centre, and we're going to start by soldering the wires that will power the Pi, red to the 5V output and blue to the ground next door. At the other end, the red goes to pin 2 of the Raspberry Pi, the 5V input, and the blue negative to one of the ground pins. I've gone for pin 6 as it's closest. We could of course use the standard USB input, but wiring direct to the GPIO pins will save us loads of space. Now a quick test to see where we've got so far, by plugging in our battery. Now, one thing we learned from the WagonCam build is we can add a little switch to the PowerBoost, and I'm going to do the same here. But instead of soldering directly, I'm going to put the switch at the end of some wires, and eventually it can be outside, accessible on the underside of my loco, while the PowerBoost is inside. The wiring is straightforward, the middle leg of my switch connecting to EN on the PowerBoost, and the one next door to the ground, completing the circuit when the switch is closed. Now when we plug in the battery, nothing happens until the switch is flicked, and we've got much more control. So far, the build is pretty similar to that of WagonCam, but now we come to the biggest difference, which is how we recharge our battery. In the original, we had to take it off the track and plug it in, but for my follow-up, I wanted to draw the current from the track, powering the Raspberry Pi and keeping the battery charged at the same time, effectively a UPS, and much safer than just a stay-alive capacitor. The first challenge here is the voltage. With DCC on the track, that's around about 16 volts. We need it to be about 5, which is where our step-down voltage regulator comes in. We also need it to be DC rather than AC, but we'll cross that bridge a bit later. Now to wire it up. At the PowerBoost end of things, we need to wire these two terminals. The one marked USB for the 5V input, and the ground next door for the negative. And that blue wire is going to go to the ground on the voltage regulator. Input and output sharing the same terminal. And then the red wire to V out, the 5V for the PowerBoost. I'm not that worried that my soldering's a bit scrappy at this stage. There'll be plenty of time in the build proper to tidy everything up. My input wires are similarly temporary, a couple of spare jumper cables with plugs on the end so I can try out my power supply options. The white one to V in, and the brown negative to the same ground terminal as our blue wire, being careful not to dislodge that while soldering. Then back in with the battery for a quick test to make sure we haven't messed anything up along the way. Now we come to that AC-DC issue. Being digital, our track is AC. It's the decoder chip that changes that to DC for the motor and other functions. And once again, I've got out my homemade test rig to see if we can't use that to power our system. Generally, I use it to try out resistor LED combos to get the brightness of my lighting right, but it's going to be perfect for what we need here. And it's one of those directional lighting circuits I'm going to be using. Brown wire to the negative, and rather confusingly, my white wire to the blue common positive. Once again, you can see how I made the chip tester in another video. But if you're enjoying the combination of tech and model railways, why not subscribe? With the lighting function off, the LEDs are showing the power to what would be the motor, a different colour for each direction. But when we press the function button, we also get power to our charger. The function voltage out of the chip is actually surprisingly high, so we really do need that extra capacity for our voltage regulator. I managed to blow up the first one I chose, but this one's coping fine, delivering a steady 5V to the PowerBoost for charging, and then onto the Raspberry Pi when we flick the switch. Orange light joined by blue and green. As well as the PowerBoost switch, we also have control over when we charge and when we don't, by using the function button, and also in the setup as it stands, inadvertently by changing direction. We can get around that by using a different function, but ultimately it's questionable if that's of any use. Which brings us to option 2, the bridge rectifier, a pretty standard way of turning AC into DC, using a bunch of diodes inside that black shell. For testing, I've pushed its 4 legs into a little breadboard, with jumper cables attached to the track output from my controller. This is the AC input, equivalent to what will be picked up from the wheels. The wires attached to the legs marked with the wiggly lines. The plus and minus of the DC output are also clearly marked, and we can plug in our white and brown wires as before, illuminating the charging light as soon as the circuit is completed. With this method, we lose a little bit of control. We can still decide when we want our Raspberry Pi operating or not, but whenever our train is on the track, it will be charging. The choice between the two ultimately will come down to which is easiest to install and attach to the loco's existing wiring, and it's time to get the body off to find out. Hornby's instructions for this are pretty woeful. The written description seems straightforward enough, but I defy anyone to work out what's going on in those diagrams. So here's my method, which starts by treating myself to a brand new 10A scalpel blade, so we've got a really sharp point. Just be very careful when fitting. Next we want an old plastic membership card, obviously one that's expired, because I'm going to cut it up into bits, using a pair of sturdy kitchen scissors, each one around about 2 by 1.5 centimeters. Then let surgery begin, by inserting just the very tip of the scalpel blade into the gap at the bottom of the body, just above the lip on the chassis. Then holding it open with a fingernail, slot in one of our pieces of plastic and slide it along the body, releasing those clips mentioned in the instructions, and importantly, keeping them unclipped so they don't just snap shut again while we go on to the others, gradually inserting more bits of the plastic card until we've got them in all the way along the body. Then with one side done, onto the other. The trick is to find a spot where the body's most flexible, and to use just the very tip of the blade, making sure you don't damage the plastic, or yourself. Then holding the lip open with the fingernail, slot in one of those bits of plastic, and slide it to the end, as far as it will go. Repeat the process all the way along the length of the body, finishing with the motor end, the one with the shorter cap. As on the 153, that's the easiest one to get off first, the lights for that end being attached to the body rather than the chassis, and you can get those bits of plastic nearer the end. Then with all clips released, it's simply a case of lifting up the body, gently easing it away from the chassis. Inside, as well as the seats, we've got the circuit board, neatly fitting under the roof so we can't see it from the outside. Fortunately for us, this is clearly labelled, and we can immediately see the two track connectors, track 1 and track 2. And even better are these plastic covers, which hold the wires in place. They're not even soldered underneath, so it's going to be really easy to add ours. And for me, that makes going for the bridge rectifier option a no-brainer. I'm not even going to look for the function wires. But that does mean we're going to need to make a little circuit board, combining the bridge rectifier and the voltage regulator. For this I've got a little bit of strip board, through which I'm pushing the legs of the bridge rectifier, so each one connects to a different copper strip on the other side. This will make wiring to it and from it much easier, rather than trying to solder to the spindly legs, which can just be folded over, in readiness for soldering. Now these things come in all shapes and sizes, so the wiring might not be quite the same as here. But on mine I've got diagonally opposite connectors for the AC input, and likewise for the plus and minus of the DC output. The positive of these has a slightly longer leg, but as my terminals are clearly marked on the top, I can confidently snip off all of them. Now we come to the voltage regulator, and we're back on familiar ground. I've removed all of the previous wiring, as we can dispense with the plug test cables, and go for a more permanent solution, twisting together the two grounds, the existing wire for the output and a new one for the input. This will go to the negative on the bridge rectifier. We'll come to that in a second, but let's finish up by connecting the other wires to the voltage regulator. Our existing red wire to the V out, and a new one to the V in. I've gone for orange to avoid confusion. Now to unite the two parts, shortening the two new cables for the voltage regulator, as I'm going to stick that onto my circuit board with a sticky fixer. This is currently very much Mark 1, and I think I can improve it later, making better use of the copper strips and where the terminals line up, particularly the common ground. And that's what we're going to start with, guiding our blue wire to the negative on the bridge rectifier and soldering in place. Then we want to do the same thing with our positive, the orange wire, soldering to the diagonally opposite terminal. And with our DC output done, we can turn our attention to the AC input, and this time we're not concerned about polarity. So I'm going to solder two white wires to the two remaining terminals, the ones marked with the wiggly line. And here's our finished circuit board, the DC output from the bridge rectifier going to the voltage regulator, and our two white wires providing the AC input, which is flipped to DC and then dropped to 5 volts, suitable for our Raspberry Pi. So let's take a look at the wiring schematic. We've got the PowerBoost connected to the Raspberry Pi's GPIO pins, supplying 5 volts from the 3.7 volt battery, which can be turned off and on with our little switch. The PowerBoost also needs a 5 volt input, courtesy of the voltage regulator, stepping down our track voltage, which has already been changed from AC to DC by the bridge rectifier. Then all we need to add is our camera, which couldn't be easier, just pulling forward the cable clip with a fingernail or small screwdriver, and slotting in the ribbon cable with the contacts underneath, facing the top of the board. Then making sure it's straight and pushed in as far as it will go, we can slide back the clamp, clipping home both ends. You'll notice, even when fitted correctly, you can still see some of the contacts underneath. Now we're really getting somewhere, and time to get the circuitry on board. The Raspberry Pi and the other components are going to sit along the chassis, so obviously we're going to need to get rid of the seats first. The blue plastic moulding also supports the circuit board, and while we don't have to remove that completely, we will need to be able to move it a bit to get to the seats below. For this, we need to take out the 2 screws from the end of the board, which hold it to the motor housing. Then we can lift the other end just a little bit, enough to release the lugs on the bulkhead. Like the body itself, the seats are held in with small plastic clips, and we can use a similar method to release them, slotting in our bits of membership card where there's a bit of flex, and sliding them along to release the clip. The ones in the middle of the chassis are a bit easier, a thumb or fingernail being enough to prise the clip open. Then when we've done all 6, we can slide the seat unit out sideways. But don't whisk it away yet, as it still has the wires for the headlights attached. We also don't want to leave our circuit board hanging, so back in with the 2 screws, and even though it's no longer supported by the bulkhead, there'll be enough to hold it in place until we do our new interior. One bit of the current one that we definitely want to keep is the front cab, with the directional lighting, so we're going to need to cut that from the seats. And rather than trying to remove the wiring, I've got a couple of sturdy pieces of cardboard to protect them while I cut the floor just behind the bulkhead with a razor saw. Eventually, I'm going to 3D print myself a new interior, with a false floor that will go above the Raspberry Pi, featuring the distinctive yellow generator, but that's a little way off, and very much a thing for part 2 of the film. Refitting the cab will do us for now. With seats out of the way, we can literally line up our components along the chassis, starting with the Raspberry Pi Zero and camera, holding them in place with some sticky fixers. The positions are still provisional, and I haven't quite worked out how the camera's going to work. I may well end up removing more of the cab. Likewise, the exact location of the PowerBoost isn't set in stone, and my switch will definitely be going somewhere else. But the main thing I want to do here is get everything on board, and working. I can refine the exact positions and wiring later on, hiding everything away as much as possible with my new interior. The last thing to go in is my rectifier voltage regulator circuit. The product description warns that this can get hot. I'm just not sure how hot with the kind of currents I'm dealing with, so I'm putting it somewhere with plenty of air around it, until I get time to test it. For now, I'm just going to hold my camera in place with a sticky fixer, mostly to stop it waggling around, and likewise the switch. This will eventually be on the underside of the chassis, once I've worked out where it's going to go, and how I'm going to get the wires to it. Then with all my new components in place, time to get them wired up to the existing stuff, which is made really easy with the plastic contact covers. These slide off the end of the board and can be pushed back on again, trapping our new wire alongside the original ones. It's a little bit fiddly, but really quite straightforward, and actually quite a relief not to have to get out the soldering iron again. It's also going to be handy for when we tidy up the cables, shortening them for the final fit, when we know exactly where everything's going to go. But first, let's put all our hard work to the test by getting our fully wired chassis onto the track and getting our power pickup through the wheels. Just to be on the safe side, I'm doing this with my DCC turned off, avoiding any shorts while I line up the bogies. But as soon as we power up, we get the orange light on our PowerBoost, so that's working just fine. And no need to mess with the function button, or worry about whether we are recharging depending on the direction. As is often the case, the simplest solution was always the best. Now let's switch on our PowerBoost and get our Raspberry Pi starting up. Of course, we don't have to be on the track to do this. We've already got power from the battery, but that's now our reserve, recharging constantly, so we know we'll never have a break in current, avoiding any impromptu restarts on the Raspberry Pi. The last thing we want mid-video. And that's what we finally come to now. After all this time sorting out the power supply, we can start talking about the camera and the Wi-Fi network feed, showing us exactly what our inspection train is seeing. First of all, our camera needs a bit more of a permanent mount. You'll notice I did indeed remove a bit more of the cab, but when the body goes on, there'll be nowhere for it to look out. And after a lot of deliberation, this is the answer I came up with, having it look out the driver's side window, held in place simply by gluing the ribbon cable to the top of the bulkhead, off to one side with the cable twisting gently behind, so as not to stress it. I'll probably go on to glue it to the dash as well, but let's make sure it works first. For this part of the film, I've got a section of my old layout out of storage. A little bit faded, and with a few chimney pots knocked off, it's going to be ideal to show the camera in action. My circular track is great for lots of things, but not this, the camera mostly recording what's outside the layout. So what we need are some straight tracks to get a more interesting view. With our hybrid power supply, we don't need to be on the tracks to power up. The battery will sort that, but as soon as we are, that will take over, keeping the Raspberry Pi running and recharging our battery, indicated by the orange LED. That'll go green when the battery's fully charged. The red light on the camera shows that that's running and already streaming video, so what we need now is to see what it's seeing, which we can do through the browser of another device connected to our network, keying in that IP address we found earlier. At the moment that's upside down, and while we've got some basic controls in our burger menu, we're going to have to dig deeper to get it the right way up. For more advanced settings you'll need to log in, the default username being admin and no password required. Here we find an extended range of options, and in general settings we can change that username and add a password if we require. There's lots of other settings, but the ones we're here for are for the video device, and it's here we can set the camera orientation, changing it to 180 degrees and hitting the apply button. Then everything is the right way up, and driving forward slowly we can see the inside of our goods shed, a little jerkily at the moment. In the same menu we can set other parameters, such as the video resolution. We can experiment with that later, but for now I just want to set the frame rate to the maximum, which even though it's not that high, will suit our purposes. If anything, adding to that CCTV look and feel, appropriate for our inspection train. Now my view here is on a laptop, but if you want to move around you can always use the browser on a smartphone. You can even monitor your layout's activity from a different room altogether, or on multiple screens, which for an exhibition layout could be really cool, giving the audience a unique perspective, the view from the train as well as of the train. But for that, we'll need to do better than the bare chassis wandering around, regardless of how interesting the electronics are. Which brings us neatly to the modelling aspect of the build, recreating the unique features of the real thing, from the blanked out windows and distinctive ventilator grills, to the specialist camera equipment and smart livery. I'll be sharing in full detail how I went about all of this in part 2 of the project. The link to that film will be on the end screen, but here's a taster of what will be covered, starting with pulling everything apart. Getting out all the windows in preparation for painting, or removing altogether to be replaced by window blanks. I'll share how I designed those in Tinkercad, along with the generator vents, ready for 3D printing, optimized to get the best results possible from my budget printer. Of course, I'll be covering the respray, from masking the bits we can largely carry over from the original, and after priming, to mixing and applying the top coat of the distinctive pale blue. And when all of that's dry, the reassembly, replacing the windows I'd carefully put aside while painting, neatly organised so I get the right ones in the right places. And then the application of my homemade decals, which I designed and printed myself. I've also got that interior to do, and the little cameras for the front and back, so plenty more to be covered before my inspection train is complete. But there's one more thing I want to share in this film, which is relocating that switch, and for that I've temporarily removed the Raspberry Pi, so I can drill through one of the very few bits of the plastic chassis, not covered with the metal weight, one of the locating lugs that holds it in place. I do need to be pretty careful because the bogie is underneath, but a strip of plastic slipped in between will stop my drill bit jerking through when it's finished. Then I can feed through 2 wires, using my strip of plastic again, this time to guide them out and over the top of the bogie. First the red and then the blue, just making sure they come cleanly out the side and don't get tangled up in the moulding. Then we can resolder our switch. It's a great deal easier to do this once the wires are threaded through, rather than soldering first and then trying to get the wires up and out through the top of the hole, as the bogie gets in the way. Then we can simply pull the wires back through the hole, bringing the switch with them. And this is where it's going to live, on a convenient bit of flat chassis, where it will be hidden away, behind some tanks and other underframe equipment. I will eventually glue it, but a sticky fixer will do for now. Then back in with the Raspberry Pi, and that will stay on the adhesive pads, which not only hold it in place, but lift it off the metal base so there's no risk of shorting any of the contacts on the underneath. Likewise for the Adafruit PowerBoost, which now the switch is out of the way, can move a little bit further down the chassis. When it's in place, we can resolder the switch terminals, red to EN, and just like before, blue to the ground. Then with the battery plugged in again, we can give the switch a test. Finally, at least for this part of the film, we can rewire the power supply to the Raspberry Pi, neatening up the wires as we go, so they no longer snag when we put the body back on. And fast forwarding to the end of part 2, we've got a very nearly finished body to carefully guide over the internal components and clip in place, ready for the layout. You can see the new switch location is much more convenient than taking the body off every time. And I'm happy to report that the voltage regulator does not get hot, so we can incorporate that into the new interior, which will also be covered in part 2. But even if you're only primarily interested in the modelling conversion, I do urge you to at least consider giving the electronics a go. They really do add a whole extra dimension to our Class 153 inspection train.